Okay, so this is the beginning of chapter 8 on vectors. And the first few days are really note heavy. So I'm sorry about that, but at one, we'll get to the fun stuff and then there won't be as many notes. It'll just be a lot of work days. To get started though, you're going to need a ruler and a protractor. And hopefully these rulers and protractors help me because normally I would do this like with my doc cam, and so we will find out if I can do it on Explain Everything. So a vector, first definition, has magnitude and length. Okay, magnitude is the length of a vector. And all vectors have magnitude and direction. And how we write a vector kind of looks like a line with an arrow, and it'll have 2 points on it, for example, P and Q. And sometimes we'll write it like this with a little arrow over the top. So we can write it as PQ or A. Both of these are good notation. And the magnitude is often represented with absolute arrow values like this. Okay? So if a vector has its initial point, so if a vector has its initial point on the origin, we call that standard position. So just like we've talked about like on the unit circle and such, it's the same. So I'm going to draw you a picture of a vector. So this will be my graph, and my vector looks something like this. And I'm going to call this one vector B. Vector B has a direction of 45 degrees. I'm just making that up, but you could measure it. So the direction is the angle made with the positive x-axis. Okay. So this is the direction of this angle, or vector B would just be 45 degrees, and they all will have an angle that will be their direction and then like a length. And if we had our ruler, I think maybe I could get this ruler to move, maybe not. I guess I can't get the ruler to move. Okay, so nope, of course it won't let me move the ruler. If I could get the ruler to move, we could measure the distance of this or use Pythagorean theorem to find it. Other notes that would be nice to have, something called the zero vector. So this has its initial point and terminal point on the origin. We call it the zero vector like this. The magnitude is 0. And it's in any direction. Okay. Two vectors are equal if and only if. This means if and only if. Okay, this is a term back from Geo. They have the same magnitude and direction. So for example, this two vectors I'm going to draw, it's pretty close, right? W and V. They have the same magnitude, they're the same length, and they have the same direction. Two vectors are opposites. If they have the same, and that's an if and only if again, they have the same magnitude, but opposite direction. So, for example, these two, vector R and vector S, have the same magnitude, they're the same length, but they go in different directions. Okay, so hopefully I'll be able to use my ruler and whatnot to be able to draw this. So the last definition today, the sum of two vectors is called the resultant. Okay. So I'm going to try to draw a couple vectors, and then we'll talk about adding vectors. So vector X is going to be 2 centimeters and 50 degrees. Okay, so if I draw in my axis here, all right, so I'm going to line up my protractor here. Might actually work. Let's see. 50 degrees is here. And then I usually take my, oh, of course not. Let me see if I can draw that spot up on here. 50 degrees would be right here. And then I take my, kind of make a spot where it would be, and then I take my ruler. And I'm going to kind of twist my ruler until I can get it to line up perfectly with the origin. I'm not doing too bad here with my fake ruler. And I want it to be 2 centimeters long, so I of course have my ruler backwards. And I keep stretching it and shrinking it, so it's not going to be a perfect 2 centimeters. But hopefully you guys will understand that it is 2 centimeters long and looks something like this. And of course I did it again. So here's going to be my, oh, and now they're connected. This isn't going well for me at all. Let's just say it looks like this. Okay, so we're going to pretend this is 50 degrees and that this is 2 centimeters. Okay, so that's my vector X. My next vector Y is going to be 1.6 centimeters and 320 degrees. So this one's going to look differently, not really differently, because 320 is in the 4th quadrant. Okay, so this one's a little bit shorter, and it should be in the 4th quadrant. So you're going to have to turn your protractor upside down. Let's see if that's something that I can do to demonstrate here. Just turn my whole notes around apparently, but not my protractor. So you will measure, like this would be 90 degrees, kind of upside down. And so it should be like, it'll be at like 40. This in here would be 40 degrees, would be my reference angle to get all the way to 360, and then 1.6 centimeters would be the length. So I've got these two, and I'm going to, now I'm going to practice adding them. So I'm going to try and draw them on another piece and see if I can work on adding these two. So here's my vector X. Pretending at least that this is 50 degrees, not percent. 50 degrees and 2 centimeters. And then vector y kind of looked like this, where all the way around like this was 320 degrees. This was 1.6 centimeters. So when you add vectors, we use what I call the tip to tail method. And I have some stuff called patty paper, and I'll have it in my classroom for you. It's like tracing paper, and it'll help you a lot if you just trace one and then bring it over to the other one. So when you add x plus y, you're first going to take x and you're going to draw it. So let me see if I can take x here, and then I'm going to move it over here. So you're going to redraw it, and you can just trace it. And then you take y, and you line up, as the name suggests, the tip of x to the tail of y. So I hope you see that I've lined up tip to tail. And what I've done, though, also is keep my kind of like my axis here, my x-axis, I've kept them parallel to each other. So I kind of drew that in blue. Okay. The resultant vector, which I'll draw in green, starts at your original spot and ends at your new spot. And from here you would measure this. So if you've done it correctly and my ruler's not working, when I did this, I got 2.7 centimeters and I got 15 degrees. Now, I might be off a little, and it kind of looks like I'm off a little bit just because I didn't use graph paper or a ruler or a protractor. But there's also a little bit of human error here. And so if you had something probably between like 2.5 and 2.9, 10 to 20 degrees, you probably did it correctly. But now I want to talk about subtracting, like if we did x minus y. And it's kind of difficult to subtract unless you think about the vector negative y as a vector. What would that look like? Well, I'm going to maybe redraw over in blue here. It would be the same vector going in the exact opposite direction. Okay? So when I do my tip to tail method again, where I grab my vector here, and then I'm going to grab my other one. Instead of lining these up like I did before with the red, I'm going to line it up more like backwards. So it's kind of like tip to tip this time because I'm subtracting it, or I'm doing it in the backwards direction. I'm adding negative y, which is the opposite of y. And so my new vector, and I can write that in green again, is this one that starts at my original point and ends where this one ended. Okay, so when I measured these, I got 2.6 centimeters and 90 degrees. Actually doesn't look that bad. But you need to be able to do this as such, and then be able to draw them. Using the patty paper helps a lot because you can just trace and then move, kind of like where I was cutting and pasting and moving. And your homework is in the packet. I think it's pages 1, 2, and 3. It seems long, though, because you have a lot of room to draw.